whenever we have a problem where we're given several initial values and we're trying to find an equilibrium value, when in doubt, ice it out. We need an ICE table in order to answer this question. So let's get to it. We'll put our I here, our C here, and our E here, right underneath our reaction. So now we want to fill out any information that we have. We know the initial values in this particular case, so we know that we're starting with 8 atmospheres of N2, we've got 8 atmospheres of O2, and we've got 4 atmospheres of nitric oxide. Okay, well, that's all the information that we're given here with respect to the partial pressures at a given time. So, since we don't know what the change is, we're going to have to use the variable minus x, and over here, it's a 1 to 2 ratio of all of these things, so we're going to make this plus 2x. And then our equilibrium values, 8 minus x is 8 minus x, 8 minus x is 8 minus x, and 4 plus 2x is 4 plus 2x. Cool. We are halfway there. Now that we've completed our ICE table, we have to pair our ICE table with its friend, the equilibrium expression. So remember, the equilibrium expression is just products to their respective coefficients over reactants to their respective coefficients. In this case, we're given a Kp, so we're looking at this reaction with regards to partial pressures. So it's going to be the partial pressure of our product, nitric oxide. And we can see there's a 2 here, so we're going to square that over reactants. So the pressure of N2 times the pressure of O2. Great. Now that we have our equilibrium expression written out, we're going to plug in the values from our equilibrium line, solve, and enjoy. Let's do just that. So our Kp value, as we said before, at this temperature is 64. Our pressure of NO is 4 plus 2x, so it's going to be 4 plus 2x squared over. And then the pressure of N2 and the pressure of O2 are both 8 minus x. So 8 minus x times 8 minus x, let's simplify this and just make it 8 minus x squared. Okay, now that we have this, we need to simplify this to avoid a quadratic. We can just take the square root of both sides. That'll make things mathematically a lot easier for us. So when we do that, we'll end up getting 8 is equal to 4 plus 2x, and this is over 8 minus x. Okay, now it's just an algebraic powerhouse. We're going to multiply the 8 minus x through, so we'll get 8 times 8 minus x is equal to 4 plus 2x. Factor this through, so we'll get 64 minus 8x is equal to 4 plus 2x. And then we're just going to add 8x to both sides and subtract 4 from both sides, just get everything to their respective side. So 64 minus 4 is going to be 60, and then 2x plus 8x is 10x. Now divide both sides by 10, and we get 6 is equal to x, and we're almost there. Then just make sure that what we're answering is what the question is asking. We're specifically looking for the partial pressure of nitric oxide at equilibrium. Is that equal to just x alone? Well, no. We can see on our ICE table that the equilibrium partial pressure is 4 plus 2x. So our pressure of NO is just going to equal 4 plus 2 times x, which we solve for as 6. And this ends up being 16 atmospheres. And we're done. Thank you for watching. Have a wonderful day.